Hey, in today's video, we are talking about why is the Northern Light green? Watch the whole video and find out this secret. Let's start the video. For centuries, people have been sharing stories of the Northern Lights. Without scientific understanding, our ancestors were forced to fill in the gaps with fantastic stories of gods and monsters. These stories taught people to respect, fear, or worship the lights of the sky. But as our understanding of the solar system and our place within it grew, these stories dissolved into legends and myths. Today, we know why the northern and southern lights occur. What are northern light? The bright dancing lights of the aurora are actually collisions between electrically charged particles from the sun that enter the Earth's atmosphere. The lights are seen above the magnetic poles of the northern and southern hemispheres. They are known as Aurora Borealis in the north and Aurora Australis in the south. Auroral displays appear in many colors, although pale green and pink are the most common. Shades of red, yellow, green, blue, and violet have been reported. The lights appear in many forms, from patches or scattered clouds of light to streamers, arcs, rippling curtains, or shooting rays that light up the sky with an eerie glow. What causes the northern lights? The northern lights are actually the result of collisions between gaseous particles in the Earth's atmosphere with charged particles released from the sun's atmosphere. Variations in color are due to the type of gas particles that are colliding. The most common auroral color, a pale yellowish green, is produced by oxygen molecules located about 60 miles above the Earth. Rare, all-red auroras are produced by high-altitude oxygen at heights of up to 200 miles. Nitrogen produces blue or purplish-red aurora. The connection between the northern lights and sunspot activity has been suspected since about 1880. Thanks to research conducted since the 1950s, we now know that electrons and protons from the sun are blown towards the Earth on the solar wind. The temperature above the surface of the sun is millions of degrees Celsius. At this temperature, collisions between gas molecules are frequent and explosive. Free electrons and protons are thrown from the sun's atmosphere by the rotation of the sun and escape through holes in the magnetic field. Blown towards the Earth by the solar wind, the charged particles are largely deflected by the Earth's magnetic field. However, the Earth's magnetic field is weaker at either pole, and therefore, some particles enter the Earth's atmosphere and collide with gas particles. These collisions emit light that we perceive as the dancing lights of the north and the south. The lights of the aurora generally extend from 80 kilometers, 50 miles, to as high as 640 kilometers, 400 miles, above the Earth's surface. Where is the best place to watch the northern light? Northern lights can be seen in the northern or southern hemisphere, in an irregularly shaped oval centered over each magnetic pole. The lights are known as Aurora Borealis in the north and Aurora Australis in the south. Scientists have learned that in most instances, northern and southern auroras are mirror-like images that occur at the same time, with similar shapes and colors. Because the phenomena occurs near the magnetic poles, northern lights have been seen as far south as New Orleans in the Western Hemisphere, while similar locations in the East never experience the mysterious lights. However, the best places to watch the lights in North America are in the northwestern parts of Canada, particularly the Yukon, Nunavut, Northwest Territories, and Alaska. Auroral displays can also be seen over the southern tip of Greenland and Iceland, the northern coast of Norway, and over the coastal waters north of Siberia. Southern auroras are not often seen as they are concentrated in a ring around Antarctica and the southern Indian Ocean. Areas that are not subject to light pollution are the best places to watch for the lights. Areas in the north, in smaller communities, tend to be best. 5 things you didn't know about the northern lights. Fascinated by the northern lights? Here are 5 facts about one of Earth's greatest natural wonders. 1. The colors of northern lights are determined by gas. The different colors of the northern lights are caused by collisions between electrons entering the Earth's atmosphere and gaseous particles. The colors depend on which gas is involved and how high in the ionosphere the reaction takes place. Oxygen causes green lights at lower altitudes, 60 miles above the Earth, and red lights at higher altitudes, 200 miles. Nitrogen particles causes blue or purplish red lights. 2. The sun ultimately creates northern lights. As mentioned above, aurora activity is caused by electrons that enter the Earth's atmosphere. But where do these electrons come from? From the sun. That huge ball of fire and gas goes through an 11-year solar cycle, which is measured by the number of sunspots, magnetic storms on the sun's surface, which are visible from Earth. The more sunspots we can see, the more solar flare energy is being released into space, eventually making its way to Earth and into our atmosphere, causing beautiful aurora activity. 3. The southern lights are a thing too. The northern lights also go by the name Aurora Borealis, a name coined by Galileo in 1619 after the Roman goddess of dawn, Aurora, and the Greek name for the north wind, Boreas. However, did you know there is also an Aurora Australis? Also known as the Southern Lights, it is the Southern Hemisphere counterpart to the Aurora Borealis and is best to view from Antarctica. When the solar activity is at its maximum, the lights are at times visible in New Zealand, southern Australia, and southern Chile and Argentina. 4. You can see the northern lights in outer space. The northern and southern lights are visible from space. Astronauts on the International Space Station quite possibly have the best view of the incredible phenomenon. 5. We aren't the only planet with northern lights. Speaking of space, Earth isn't the only planet with aurora activity. NASA has shared photos of the lights captured on Saturn and Jupiter. In fact, auroras have been observed on Jupiter, Saturn, Uranus, Neptune, Venus, and Mars. That leaves only Mercury as our galaxy's lone planet, where an aurora has never been observed. In addition, Jupiter's moons, Io, Europa, and Ganymede have been observed with lights as well. The colors of the northern lights. The colors of the northern lights are determined by a number of factors. 1. The composition of gases in Earth's atmosphere. 2. The altitude where the aurora occurs. 3. The density of the atmosphere. 4. The level of energy involved. The northern lights can be spectacular. The bright pink fringe on the lower edge of the aurora occurs when electrons strike nitrogen in the atmosphere. The following colors can be seen when the northern lights are in the sky. Green. Green is the most common color seen from the ground and is produced when charged particles collide with oxygen molecules at altitudes of 100 to 300 kilometers. Red. A bit higher in the atmosphere, at altitudes of 300 to 400 kilometers. Collisions with oxygen atoms produce red auroras. Blue and purple. Finally, hydrogen and helium molecules can produce blue and purple auroras, but these colors tend to be difficult for our eyes to see against the night sky. How are the colors of the aurora created? The sun radiates all visible colors, which is why sunlight appears white. The spectrum of visible light associated with the aurora is much more restricted. The aurora is caused by charged particles in the solar wind colliding with atmospheric atoms and ions. The collisions cause the electrons of the atmospheric atoms to become excited. As the electrons return to their original energy levels, these atoms emit visible light of distinct wavelengths to create the colors of the display we see. The color of the aurora depends on the wavelength of the light emitted. This is determined by the specific atmospheric gas and its electrical state, and the energy of the particle that hits the atmospheric gas. How are the colors of the aurora created? The sun radiates all visible colors, which is why sunlight appears white. The spectrum of visible light associated with the aurora is much more restricted. The aurora is caused by charged particles in the solar wind colliding with atmospheric atoms and ions. The collisions cause the electrons of the atmospheric atoms to become excited. As the electrons return to their original energy levels, these atoms emit visible light of distinct wavelengths to create the colors of the display we see. The color of the aurora depends on the wavelength of the light emitted. This is determined by the specific atmospheric gas and its electrical state, and the energy of the particle that hits the atmospheric gas. The atmosphere consists mainly of nitrogen and oxygen, which emit the characteristic colors of their respective line spectra. Atomic oxygen is responsible for the two main colors of green, wavelength of 557.7 m, and red, 630.0 m. Nitrogen causes blue and deep red hues. Most of the auroral features are greenish yellow, but sometimes the tall rays will turn red at their tops and along their lower edges. On rare occasions, sunlight will hit the top part of the auroral rays to create a faint blue color. On very rare occasions, once every 10 years or so, the aurora can be a deep blood red color from top to bottom. Pink hues may also be seen in the lower area of the aurora. In addition to producing light, the energetic auroral collisions transmit heat. The heat is dissipated by infrared radiation or transported away by strong winds in the upper atmosphere. Do other planets have aurorae? Any planet with an atmosphere and magnetic field is likely to have aurora. Scientists have captured incredible images of aurorae on Jupiter, Saturn, Uranus, and Neptune. Aurora on Mars have also been seen. But as the red planet does not have a global magnetic field, aurorae behave differently and appear to be far more widespread. If you love similar content like this, take a look at my other videos. And if you like it, please smash the like button. If you have further questions, feel free to comment down below. See you in the next video.